maybe to tackle this, maybe zooming in a little bit onto this box now that we're talking about Aura. So Aura, you build an Aura window tree that translates directly into a CC tree. On desktop today, we don't use the thread. The reason we don't use the thread mostly is that the UI is responsive, so we don't have the same problem as arbitrary content blocking the main thread. It's like we control everything. We control the entire thread and control what runs there. So there's no direct reason to enable the thread in the UI. The one reason we do it on Chrome OS is we have better scheduling than the GPU when we use the thread. Though it's something that we could also do without the thread, which doesn't have the code for it. The scheduling I'm talking about is we can get feedback from the GPU about vsync, so that instead of waiting for the GPU to block to tell us, hey, stop doing things, we know preemptively, oh, vsync will be at this time. We're going to try to align on this to say, hey, render starting here, render starting here. Hopefully, as long as we can render everything within one frame on the GPU, it will not block. Because it will not block, it leaves more time for the renderer to put its command versus the browser and so on. But anyway, from the Aura, from the browser point of view, you have this layer tree, this window tree. One of the windows is going to be the window that's representing the renderer. I feel like I lost everyone already.
Yeah. Back into the...
No, I mean, it just means there's going to be an entry in the layer tree for the web contents, right? So it knows where to draw it.
I think, we're...
By window you mean Aura window?
An Aura window, yeah. So this is one of the things I have in my list at some point. It will be good to talk about the relationship between Aura windows and layers, and I think we mostly cover layer and texture, but
the relationship between Aura windows and layers is essentially one-to-one. An Aura window owns a CC content layer. The content layer, the way it works is during this commit here is the time that we're going to call the layer client or delegate, I forgot how we call it. That goes up, from here, goes up, say, paint this rectangle. And the reason it says paint this rectangle is because the UI said, so let's draw a basic UI. You have a window, you have a tab bar, a URL bar, and then tabs and stuff. Simplistically, in Aura, as far as I've seen, you have one window here for the web content, and you have one window that's actually all of this that contains this one for the UI. And essentially the UI says, well, I changed the text here for the tab, so I'm gonna tell the layer, hey, I changed this bit. I changed this area. What we call invalidate or set needs display, or I forgot exactly how it's called in Aura. We can find that if you want.
I think it's a schedule draw? No. Schedule paint.
Schedule paint, yes.
Schedule paint.
Not schedule draw. Oh, terminology. Something that the compositor team is using, paint versus draw. Paint, yeah, I know. Sorry, didn't come up with it. Paint is creating the software bits.
Yeah.
Draw is taking all the layers, putting them together.
Yeah, I think basically paint is all related with Skia, and draw is all related with CC and GPU.
Taking all the layers and putting them together, why isn't that just called composite? Isn't that what composite means?
It's too long to type,
Yes.
so method names.
Okay.
Composite
It's
is
called
putting them
draw.
all together.
Fine.
Draw is like, it's more like taking one layer and putting it anyway.
Okay.
That's unfortunate, but that's the terminology that we use, so that's what it is, sorry.
So schedule paint.
Right, and so you give it a rectangle that says, hey, next time you're gonna wanna draw things, ask me for those bits. The CC layer keeps track of all those rectangles, and then during commit, or before the commit here, before we do this, we update all those layers and say, hey, I have this rectangular area that I need to paint, so I'm gonna call back to the embedder the layer, content layer client, which ends up in the UI layer, which ends up calling a layer delegate, which is the Aura window, which calls to its delegate, which is the view, and so on, to say, here's a canvas, a Skia canvas, give me all the Skia commands to render what needs to be rendered here. And as far as I understand, it goes through the view hierarchy and asks all the views to paint, whatever it needs to paint in that region. So that happens for all the layers in existence. It happens, and then we, even when we don't use the thread, we still have those two layers. They just coexist on the same thread. But basically, the commit phase is where this happens, and then we can start drawing it. When we don't use the thread, we're going to draw right after the commit. The reason we go through a delegate instead of saying, each layer says, oh, paint this, paint that, is mostly for scheduling purpose. We don't want to have every layer trying to animate itself and start painting things faster than the compositor can consume. The compositor will only consume it once per vsync at most, if at all. Like if it takes even more time to draw, then it's going to do it less. So this guy here, as we said, is an Aura window, and this guy, render widget host view Aura, which lives inside of content, is basically what makes the bridge between the renderer and the UI. It has an Aura window. And depending on what the renderer does here, whether it's the software, the old software case, or the accelerated compositing case, will decide what data it puts into its layer, and actually what type of layer it will create, content layer versus texture layer. In the old path, non-composited path, we have basically a backing store, which is a bunch of pixels, and we're going to say, hey, we're just going to create a content layer for this, put it in, basically doing the same thing, schedule paint, giving whatever came from the renderer, that direct. On commit, the compositor will ask for those bits, we'll put it there, done. For accelerated compositing, we receive a texture here from the GPU process that we know how to associate with the renderer. We know it corresponds to that renderer in particular. And we grab it, we put it inside of a texture layer instead. And the compositor will do the commit. There's some scheduling that happens here in that for this ACK here, we're going to make sure we don't ACK too fast. We're going to throttle it on the commit so that we throttle all the way back to the renderer to say, we don't want the renderer to try to render faster than what we can consume in the UI. Any questions so far?
So say the audio indicator. The audio indicator is in that window.
Yep.
And it's just this little square, or could be the blinking cursor in the Omnibox, whatever.
Yep.
So that calls schedule paint.
Mm-hmm.
Schedule paint calls schedule draw.
Eventually, so it will go inside of CC. CC will say, oh, we have changes, we have something that changed, so it means that we have to do a commit and a compositing pass. So this will call back with schedule draw if you don't have the thread.
Mm-hmm.
Schedule draw basically goes back to Aura, and Aura decides, oh, I need to explicitly tell the compositor to do the commit and the compositing pass. Because we share the thread, the compositor cannot say, hey, I'm gonna do everything by myself whenever I feel like it. So that is what schedule draw is. Schedule draw is the compositor telling the Aura layer, and in particular the root window which controls this, that I need to composite because you told me to, essentially, but I need to composite, so whenever is a good time, tell me to composite. And then the Aura root window calls back and says, composite now, whenever it's ready. Essentially, it posts a task and keeps track of how many there are in flight. But anyway, the Aura root window calls composite. So it goes back into CC. CC says, oh, okay, I'm going to do the commit, so I'm going to do the update. I'm going to call back for every layer that had a dirty region, which in the case of the audio indicator was this.
Mm-hmm.
Paint those bits.
So we draw the mouse cursor with the GPU, right?
No.
No?
No.
So how come when I move the mouse like this, the GPU usage goes up?
Oh, easy. Well, easy. When you move the mouse here, either here or here, but typically here, the entire UI stack says, oh, I want to draw a highlight around the cursor.
Mm-hmm. You see how we have a little bit of,
It's barely visible at all.
yeah.
But basically, if the UI says dirty this, because the cursor is here.
So if it's barely visible, why don't we just not draw it?
Looks pretty.
Oh, you have to fight with the UI people. There is a halo that goes around the mouse.
You'll also
on
have
the-
to fight with Sergey. He loves this.
Yeah?
Yeah.
Damn it.
I like it.
So run chrome.exe -- Sergey. And then you get your halo.
So
Yeah.
basically, you're running this entire stack anytime you're moving the cursor here. Here, it depends on what the render really does. Sometimes it's going to say, oh, well, I'm going to change the style because you're hovering over a link. So the link becomes bright instead of not.
So if
do
you're
that
not
impulse-
if you're not doing anything and there's no animation on your page and you're just sitting there watching your screen, are we blidding every frame or not? No,
No.
right? Okay.
So back to this sort of,
So regular invalidations which happen because a window moved in front of the browser window, all that is done through the GPU or?
so if on the desktop, if you have exposure coming from another window coming off, what's going to happen is it's going to generate a Windows event.
WM Paint.
WM Paint.
Paint.
WM Paint will go to the UI, and the UI is going to say, oh, I lost some of the bits. I need to tell the compositor to redraw those bits. So it's not, at least in theory, it should not be a scheduled paint. It should be a, I forgot how we called it, invalidate rect or something like that. That does the scheduled draw. The reason it's not a scheduled paint is we don't need to repaint those. We have them. They're in texture on the GPU. We just need to redo the draw. We just need to do that.
Yes. Yeah. It's another name, I don't have it here though.
Okay. Still, I talked about Aura on Chrome OS, which is somewhat simple because it's Linux. Aura on Windows. As we mentioned, well, okay, backing up. Aura on the desktop. On Chrome OS is easy, we just have one window for the entire thing. Or technically one window per screen, but it's easy. On desktop Aura, what's happening is you create a top-level window for each top level window, all done. But that means you have a lot of them, possibly. So you have many what's called Aura root windows. Each of them owns its own compositor. As we mentioned here, the GPU cannot draw directly to the window, so we still have this flow of the GPU sending a message to the browser saying, you know, after the CC sends all these commands and goes all the way to the swap, the GPU goes back to the browser to the swapping thread saying, bleed this, present this. So what you can see is the renderer starts to draw, it sends a bunch of commands, goes to the GPU, goes to the browser says, oh, I got a new texture, I'm going to swap it there, goes to CC, CC decides to draw, sends more commands to the GPU, this goes back to the browser for the final present. That's the entire pipeline. What else? Questions so far?
Yeah. Well, I guess we should mention for completeness that in Metro mode we draw via another process. So
I don't know how Metro mode works, so you on the hook.
It's got a hack in it, hasn't it?
we're gonna hack it. So
Same process.
so there's another process that needs to run in Metro mode, and it runs in a sandbox that is not our sandbox, it's an app container sandbox. And this process has Chrome exe, and it should only be loading Metro driver. There is no Chrome.dll in this process at all. So it should be relatively nimble. And what it does is that we discover that if we create the device, the 3D device, and we set up the swap chain, we can actually present to the Metro process directly from the GPU. No, actually from the browser.
We absolutely will not break in a service pack, will it?
No. Well, there was a worse hack in the previous version of Metro. And in the
hack had to change.
By present, you mean you just send the H window over, right?
No.
Well, so there's a function that says get accelerated widget, and we pass the SSH window to over there via an IPC. And then, from the perspective of the browser thinks that's its window, but it's the window of this process. And it just bleeds on that. You can bleed. We don't think it's gonna break, which means that other process could actually present, I believe, to any random window, as long as the swap chain is properly configured, I think.
So the Metro window isn't even on a different desktop?
It's not a different desktop. It looks like a different desktop, but it's just
Yet.
emulation. It's not a jet, yes. It is Cloak, but it's not a different desktop. Yeah, so
What time is it? We have time to do OP layers and CC layers and
So we can
Uber
talk
comp
about
and-
this, how do I video decode Aura Compositor, and I don't know how much you guys want to touch about the software compositor.
All of that sounds great, but
Yeah, friends.
So if there are painting issues, so then is there any code for deloading built-in which dumps the damage threads and stuff?
Mostly what we use at this point is about tracing. We're trying to increase the data that we surface there. There are a few in the render from the DevTools in the browser. There are some flags where you can dump, like you can have the compositor dump it can dump it can show the layer borders. So it's gonna basically show a rect with a given color around every of the layers. In the case of a tile layer, it's gonna show you the tiles. So that's one. Two, he has a mode where it's gonna draw, I believe, red, various shades of red, based on what gets repainted. Well, redrawn or repainted. So, for example, you move a layer here, assuming the tiles are all good. You may not have anything to repaint, but you may need to redraw. You know, it's essentially similar to exposure. So if this layer moves here, you're going to see a reg that is, from here to there, saying, oh, we need to repaint what's there, and we need to repaint the exposition. Redraw. Sorry. There's another color, I think, that shows what gets actually repainted, the invalidation that happens at the layer level of saying, hey, well, we needed to invalidate this, so we discarded the pixels and asked to draw again. I forgot the name of the flag, it's like dash. So there's a bunch of compositor CC flags that tune these things. And there's always a --UI version of it. So if you go into CC debug flags or CC flags .cc, you see all the flags, and you usually see either next to it or possibly there in another place a --UI version of this one. So --UI show layer composited borders or whatnot for Aura.
So you have a list of things there?
I'm adding software here.
Yeah. So, do you wanna talk
Go down the list.
about? I mean, which one?
So I don't know that the WebKit layers is very relevant to this group, and I don't know it very well.
It's not relevant for us.
Do you want to talk? I think those two are somewhat important because they affect you.
Mm-hmm.
This one is, I know a fair amount about it. I don't know if you're interested or not, or we can leave it for later.
Yeah, we can make lower priority.
Okay.
We can put it, yeah.
Okay.
Aura Compositor and software.
Okay, Uber Compositor and software. I think Uber Compositor is somewhat simple to, it's not a big deviation from this. Essentially, the idea is, as I was saying, doing 2 levels of compositing is a waste. Instead, what we can do is take all of these textures here, generated by the renderer, give them to the browser, and then the browser can merge all these textures, this list of texture, with the list of textures he has to draw. When I say textures, is what you see inside of CCS called quads. So a quad is essentially a texture and then a set of coordinates and whatever we need to know how and where to render it. So essentially, Uber Compositor, what it is the renderer will still do all the GPU stuff he has to do to generate those textures. So whether running the WebGL render this, or uploading the bits to those textures, then send an IPC to the browser. I guess this is where it changes a little bit. To swap a frame, instead of going through the GPU process, it goes directly here from the renderer to the browser, saying, here's my new frame. I'm using these 100 different textures, each with an ID, and I'm using this list of quads, all referencing those different textures. The browser gets it and puts it into a special type of layer called a delegated render layer. Which basically, instead of, it looks a little bit like a texture layer, but instead of taking a single texture, it takes a list of quads. It goes through this entire same process. When comes draw time, where we generate the list of quads to draw, we just merge it at the right place. And then the browser will then send the commands, including those. And that's how we save a copy. So I guess the major difference in the Aura Compositor is the synchronization. Essentially, we don't have these anymore, which is actually good architecturally. We still need some sort of synchronization because the renderer sends commands here, the browser sends commands here. You want to make sure that the commands of the renderer that generated all this texture happened before the ones from the browser. So we have this thing called, in the command buffer level, called sync points, which essentially let us make sure the commands happen in the right order. But aside of that, basically the browser sends event, the renderer does its rendering, sends a message to the browser makes its rendering. We don't have those cycles anymore, which is good. That's essentially it. I guess where we're going with that too is, so we're using a new message called Swap Compositor which we send directly from the compositor thread when we finish drawing. Progressively, we want to take everything that we used to send in the update rect, including the input ACK, resize ACK, the plugin stuff and everything. We want to fold it into that and get rid of this eventually, future. The browser picks this up, gives it directly to this guy. This guy knows what to do with it. The ACK comes back directly from the browser to the renderer without going to the GPU. But we have essentially the same scheduling overall.
When is this supposed to land?
Okay, we're gonna try to enable it on Chrome OS soon, very soon. It almost works. There's subtle, small issues, but it should be fine. We're thinking of enabling it on desktop Aura as well, as soon as possible. It will probably help with some of the crazy cycles, deadlock, and things, because we don't have this cycle, and we're hoping, it's a flag, so it's easy to disable, but we're hoping that it will not directly affect Aura desktop any more than Chrome OS. If anything, it's worse on Chrome OS. And so we'll be able to fix all of this. We'll probably enable both of them on Chrome OS and desktop together so that we have one architecture on Aura, not two. Any other question about?
When you say there's no sync, doesn't the GPU have to, like, doesn't the browser, or there's no backfill in or something? Like, how does the, because before it was getting throttled by the browser getting the GPU when it was finished.
It still is, but, okay.
So the browser goes only to the GPU, but it doesn't go back to the renderer, it goes back to the browser.
Before, so, browser, renderer, GPU. We have,
Where's A?
the renderer decides to draw, so 1, 2, so the renderer draws a frame, sends a swap, the browser draws its frame, 3, gets an ACK from the GPU, 4, sends the ACK for the renderer, 5, goes back to the renderer, 6, okay? Yeah.
Yeah, it's just
With the swap compositor frame, it's like this. The renderer draws to the GPU, 1, sends 2 to the browser, 3, the browser draws its frame, gets the ACK, sends the ACK to the renderer.
Why does the renderer, why in the original case does the browser's renderer have to go through the GPU?
It's sort of a simplification. We're doing more pipelining into that, so
So look at the code, yeah, okay.
I mean, for the first frame, we can ACK directly to allow pipelining, to allow the renderer to move forward. The second frame, we have to wait until the previous frame of the browser has rendered.
The renderer has to wait? GPU
Well,
has
we
to-
don't want the renderer to go as fast as it can without waiting for the browser.
And we rely on the GPU to slow down the renderer.
Right, we rely on the ACK
Yeah.
flow, what we call the back pressure of saying, once the GPU starts throttling because we try to go too fast, the ACKs won't come to the browser. Because of that, the ACKs won't come to the renderer, and the renderer will stop as well. Yes, this is the tricky part of the infrastructure and cause of countless bugs. Anyway.
Confusing. A little confusing.
And those don't include what happens when you have an NP API plugin on Windows.
Yes.
Right. Let's not talk about that.
No, it's not.
We're gonna deprecate those soon anyway.
Yes.
Yeah, I don't know that.
I guess software compositor. Yeah.
So we built this entire infrastructure using a compositor and everything, and then it all relies on having a GPU here. The problem is, what if we don't have a GPU? What do we do? So originally, in the old case, before Aura, we were like, oh, well, you just don't get compositing in the renderer. All this, like if you don't have a GPU, you don't get WebGL anyway, you don't get accelerated features anyway. So we're just going to revert to the old style things. So it's very simple. We still have the transfer dibs, and the browser will just read it onto the window. Once we start moving the browser to the compositing architecture, we're like, what do we do now? And in particular, because we cannot have both the non-Aura and the Aura versions together in the same process, we have to make Aura work in software. There's two ways we approach this. One was to say, hey, we have a software implementation of GL called
Swift shader.
Swift Shader. Can we just use that? We tried, and it was slow. And we didn't think, well, it was fast enough on high-end machine, but on low-end machine, it's just not good enough. And we felt that we would not be able to make it fast enough. Essentially, the high-level problem is we're describing in GL everything as 3D things with arbitrary programs running on every pixel, whereas really what we need is just being able to do blades and stuff. But essentially it's sort of solving the halting problem of saying, oh, we know what this shader does, we can replace it by a blade and so on, and it becomes very difficult. Instead, what we said is, can we implement CC using a 2D API, which is Skia, instead of GL? So almost all of this works exactly the same way, except once we get to the drawing phase, instead of sending things to GL, we send things to Skia. So that means, some things won't work. If you have a 3D transform, it won't work, at least it won't be perspective correct. But Skia can do a lot. It turns out it can do 99% of what we can expose in CC and does 100% of what we need in the UI. So what we decided was, let's do that. Instead of having a GPU process at all, CC will render to Skia to a software buffer instead of a texture. We're going to send that to the browser. The browser will put it inside of a content layer, or actually, no, technically, it's still called a texture layer, but it takes a software texture. We'll draw everything and then relate it directly onto the window. So, because we don't have a GPU here anymore, synchronization-wise, this old-style thing doesn't work anymore. So Similarly, for the software case, we use this message, the Aura Compositor free message. It goes directly from the renderer to the browser. We still have all the benefits in the renderer of having a thread, so we have smooth scrolling even in software. What's left is basically, plugging everything through, and I mean, this has already been done. And except currently, those two, Aura Compositor and software, don't work together yet, though we're working on that. Still, what it means today is the path to get pixels on the screen from the renderer is the renderer paints this. We draw it using Skia, which means it's a bit. We take the result of that in the browser, put it inside of the texture layer, and then the browser as well does a blit during its draw phase. So we have 3 blits before getting to the screen. Aura Compositor will save 1. The other thing that we have today is in the old style software case, when you scrolled, you could say, you could tell the OS, take the content of the window, shift it up, and I'm going to give you the rest. This is not something that we have today in CC. We don't have this concept of, hey, I'm drawing a frame by shifting the previous frame around. But we want to add this so that both the renderer can send, hey, what I did on this frame is just shift things around. Send this to the browser. The browser can take that into account and say, I'm also going to shift this